Hello and welcome back to Calculus 1. We are starting chapter 3. We're going to explore derivatives. So we said calculus consists of 3 topics: limits, derivatives, and integrals, where both derivatives and integrals, at least the definite ones, are going to be described, explained through concept of a limit. Now, the mechanics of 3.1 are actually just taking limits, so this greatly reinforces your knowledge from solving limits from 2.3, where you have to use algebra and other similar witchcraft to solve problems. So 3.1 is theoretical plus limit calculations. So let's see, go all the way back to first state that 2 points define a straight line. We have, say, point A, point B. Point A is x1, y1 as coordinates, and point B is x2, y2 as coordinates. And you are able to write y equal mx plus b because we have a formula for slope y2 minus y1 over x2 minus x1, which is in charge to find the slope. Once you find the slope using those 2 points provided to you, you can use one of the points as x and a y, and you have computed m, so you can find b, and you can write the equation of the line. So if you have 2 points, you can definitely find the equation of the line by following these simple rules. Now, I'm going to introduce some pre-calculus into the mix. So we are going to look at a function f of x, and then have 2 points on that function. Now, if that point is A and B, then each one of these points is A f of A and B f of B. Now it's a straight line. F of A and F of B are y values, so our good old slope formula, instead of using x's and y's, right, we have the notion that y is now f of x. I can recast this formula as f of x2 minus f of x1 divided by x2 minus x1. Or, to use the letters from our picture, slope would be f of b minus f of a divided by b minus a. Whatever you want to use. We still see the same formula from your Algebra 1, elementary algebra. y2 minus y1 over x2 minus x1. Because that is the way to compute the slope when you have 2 points. And that's the end of the story. Now this line is called the secant line, from the Greek word to cut. Because this line cuts through the function, right? It cuts into 2 parts, 2 pieces. So we will call this slope m secant. So I'm just going to add SEC for secant, which means to cut. Now, what I'm going to do secant, to cut in Greek. So what I'm going to do now is I am going to introduce some calculus over here. I'm going to make point A fixed point. And I'm going to let point at B to go towards A. So new picture, which will pretty much look the same in the beginning. So there's my function f of x, my x-axis, my y-axis, and my, let's go here. In the book they're using P and Q, so fine, all right. P and Q, and this Q, so P has x coordinate as A, right? But Q, since I'm going to let Q go along the curve, Q will not have B anymore. Q is going to have a variable x, because as Q moves, the value of this point moves towards left, taking on all of the values going towards A. So I cannot put B any longer. It has to be a variable now, because it's changing. That's the definition of a variable. It changes. So point P is fixed point, so I can use A because it's fixed. But point Q is the one that's going to move, and its x coordinate is going to become a variable now. So I'm calling it x. Now, Q is going to be here, and then eventually there, and then eventually there, and then here, and then here, and then it's going to collide with P, right? And then it's going to pass it, and it's going to go forever, right? Down the line. Now I'm going to draw all of these secant lines. So from P to the next stop, 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 and then they collide. P and Q become one. Now, what is happening with my calculation for the slope? What is happening with the slope calculation? So m secant is going to be f of x minus f of a divided by x minus a. Right? It is this point, which is like x2, y2, minus the fixed point, which is a f of a, x1, y1. Now, please note that as this q goes from q to q prime, to q double prime, to q triple prime, and so on, the coordinates of this pair keep changing. And I hope that you see that there is an issue with this calculation as the 2 points collide. Because when Q runs into P, what are the coordinates of Q? Same as P, which is a f of a. So your calculation becomes f of a minus f of a over a minus a, and yeah, good luck computing that, right? You have 0 in denominator. It's an issue when they collide. But nevertheless, you can see the progression of the blue lines, which means that has to be a line going through this P. But we only have 1 point to compute its slope. Sheesh. So algebra doesn't work anymore, right? Now, do you see a concept which helps us fix this? Limit. Regard every blue line, every slope of the blue line in this progression as infinitely many calculations around the red line, except at the red line. You remember that that was the exact concept of the limit, that you compute every single value except at the value? Well, now you can't compute at the value. You get 0 in the denominator, right? But you are able to use the m secant to compute all the blue lines. The red line is called the tangent line, one of the central concepts of Calculus 1. Arguably the most important concept of Calculus 1. Tangent line. And the tangent line, so that's this red line, and the tangent line has the slope m tangent, which is equal to the limit of m secant as x goes to a. Now that's concept. You can't use this to compute anything. But it's a mathematical concept and one of the most important ones that we have in Calc 1. So now you might go, so what? Let's see. So now what I found is that the slope of the tangent line is the limit x goes to a of f of x minus f of a divided by x minus a. And yeah, not really user-friendly to compute things. So what am I going to do? Well, I'm going to make a substitution, mathematical manipulation. I'm going to let age be equal to x minus a and use it to eliminate all x's. Well, if I'm eliminating x's, then x better be age plus a, or a plus age, whatever. A plus age, there we go. So this is the consequence, right? So we make the definition, age equals x minus a, which is the denominator. And then from there, if you solve for x, because we need it for substitution, you get this. Now look at these little clever things over here. You subtract a on both sides. You know that this whole thing is already age, and you can replace this x over here with a plus age. So we're good. We can kill all x's that way. So let's do it. Subtract a on both sides. We get m tangent is equal to the limit x minus a goes to 0, right? And then you have your f of, instead of x, I have a plus age minus f of a divided by x minus a, which is age. The only thing that is left is to replace x minus a under the limit with age. And what is this formula? Anyone? Anyone? What is it? Difference quotient. This formula to compute m tangent at a, at x equals to a. Much better. So m tangent at x equals a. That x equals a, that's very important there. Great. Let's Let's do it. Find m tangent for f of x equals, say, x squared plus 2 at x equals, say, 3. So find the slope of the tangent line for function f of x equals x squared plus 2 at x equals to 3. All right? So this over here, right, this over here and this over here tells me that a is how much? 3. A is 3. So this over here tells me that a is equal to 3 because I need to plug that in. Great, let's do it. I need f of a plus h. All right, fine. F of a plus h is actually going to be f of 3 plus h. And now I replace that function composition, replace every x with 3 plus h. Sure. The only x that I have is the one that is squared. So that's 3 plus h. And then I'm going to do algebra now. So 9 plus 6h plus h squared plus 2 is h squared plus 6h plus 11. What I have is this piece of the formula completed. Now I need to find f of 3. That's the next piece in the puzzle. So f of 3 is, when you plug 3, so 3 squared plus 2, which is 9 plus 2 is 11. That gives me this part of the formula. So if you want me to color code it for a second, that's 11. And this part of the formula here is this, right? So I have two pieces of the formula that I need. I calculated both of those, and all I need to do now is to plug everything in. So what's the slope of the tangent line? M tangent. It is the limit h goes to 0 of f of a plus h. Well, that's my h squared plus, you know what, I'm going to write the formula one more time. So f of a plus h minus f of a divided by h. Plug everything in. Do not forget the limit in every step. It's minus 2 per step, so you might end up with the negative points per problem. Alright, so limit h goes to 0. Our f of a plus h is h squared plus 6h plus 11 minus f of a, which is 11, divided by h. These 11s cancel, and if you notice, the surviving terms all have h, and you can kick h out. So limit h goes to 0, you kick h out, you are left with h plus 6 divided by h, and now h dies. And now when h goes to 0, the answer is 6. So, do you see what just happened? You gotta be much more excited than that, guys. Your whole life you were told that the slope between the 2 points, right? You have to have 2 points. We just computed the slope with 1 point.
Whoa.
Really? Thank you. Holy nightmare. This is huge. Your whole life. And delusion. Right? You have to have 2 points and then you have y 2 minus. No, here's it. 1 point only. Look at that. And we have the slope. M equals 6. Got it. I didn't even have the whole point. We just said x equals 3. Right? We just got a 1 coordinate of 1 point. And we were able to find. This is power. And the more you learn, the more power you'll have. Still nothing? You're dead inside. All right. Oh wait, was that x equals to 3? I actually wanted x equals to 5. From scratch. The function is still the same, so don't worry about that. So f of x is, what was that, x squared plus 2, right? But I wanted x equals 5. All right, that's fine, it's fine. We can do this quickly. So f of 5 plus h is going to be 5 plus h squared plus 2, which is 25 plus 10h plus h squared plus 2. So the total thing over here is h squared plus 10h plus 27. Okay, good. And f of 5 is 5 squared plus 2, which is 25 plus 2, which is 27. Good. And now we compile the limit. So limit h goes to 0, right, to find our slope. Actually, I should write that. Yeah, do this in your notebooks. M tangent is equal to the limit h goes to 0 of h squared plus 10h plus 27 minus 27, because it's minus f of a, divided by h. The 27ths die, and we can factor h. So we get h plus 10 over h. H goes to 0. Now the h's die. And we get that the slope of the tangent line is 10. Yay. So that was at, what? X equals 5. I actually didn't want 5. Let's do it for negative 4. And I'm pretty much sure that once we're done with negative 4, I want to know how much is like a 248. Yes.
How come it's like when you get h plus 10, it's like the limit equals 10, when it's negative 10, you bring it to the other side and you know what I'm saying? At the last step, when it's h plus 10, how come it just equals 10?
When h goes to 0, all that's left is positive 10.
Alright.
Right? You're calculating now because there's nothing, so you can just plug in h is 0 and then you get 10. So what do we have? We calculated the slope when x is 3. We calculated slope with x is 5. And now I want negative 4. After that, I'll probably want, what, 248? You see the issue? The calculation goes over and over and over again. Same calculation all the time. So, and the only thing I'm changing is this number, right? But as soon as I change that number, this changes and this changes, everything changes, right? So recalculating the whole thing is inevitable. Unless you solve the problem for all x's first without plugging in 5 or 3. Right? So you know what I'm going to do now? My good old m tangent, which was limit age goes to 0 of f of a plus age minus f of a over age. And that a was pinned down by what was given to you, like x equals 3, 5, negative 4, whatever. I'm going to remove that requirement. I'm not going to give you what a is. I'm just going to say compute it for all possible x's. And that changes your formula. M tangent becomes limit age goes to 0 at f of x plus age minus f of x over age. And this is the formula you guys are used to as a difference quotient formula, right? So now, if I ask the same question, I'm not going to compute a single slope. I'm going to compute all of the slopes that are possible at every point. And then later you can ask, okay, so what's at 3? Well, let's see what happens. So what is now if my f of x is x squared plus 2? Right? Can I find all slopes? And the answer is yeah. M tangent is the limit age goes to 0. And now I have f of x plus age minus f of x over age. All right. Well, let me find f of x plus age first. That would be x plus age, everything squared plus 2. So whatever was here is replaced. So replace it on the other side of the equation. Remove x, include x plus age. So once you have that, you get your x squared plus 2x age plus age squared plus 2. That's what you have when you expand. Don't forget to use the middle term for this. I mean, I didn't talk about it, but middle term is always there, guys. 2ab. Learn the formula. So now I have this, and now I can plug everything in. Right? F of x is just the function itself, so m tangent, but all of them, not a specific one, all of them, is going to be limit age goes to 0, and now I have x squared plus 2x age plus age squared plus 2 minus f of x, which is x squared plus 2. Everything divided by age. We gotta clear some algebra now. Let's have fun. Limit age goes to 0. I hope you see. Now I'll write it out. X squared plus 2x age plus age squared plus 2 minus x squared minus 2 over age. X squared and negative x squared die, and positive 2 and negative 2 die, leaving behind only terms with ages where you kick one age in front. So limit age goes to 0, age goes in front is 2x plus age divided by age. These guys cancel, and as age goes to 0, your answer now is 2x. Now this over here will generate all of the slopes. You remember your x equals 3? Well, slope equals 6. Didn't we compute for x equals 5 and you got 10? You replace those values that you want the slopes for. There, 2 times 3 is 6, 2 times 5 is 10. Now you can ask any slope. I have a formula that will generate every single one of them for this particular function. So remember how I wanted -4? Great. M is -8. I also talked about 248. M equals? Very good. So I can generate any slope now of the tangent line. What's the name of this function that generates all the slopes? It's called the derivative. That's what the derivative is. Derivative of the function is a function which will generate every tangent line slope that is available to that function. So this function over here is called the almighty derivative. So, in blood, here, the derivative function generates all tangent line slopes. For given f of x. That's what derivative is. And the way to find it is through the limit of the difference quotient. So in pre-calc 1, they show you the difference quotient formula. They tell you memorize this thing, you know, play with these problems a little bit, that's it. But now you see that that defines something that pushed the whole humanity to another level. Because these derivatives, the slope of the tangent line, we'll see that in chapter 3, measures the change, the instantaneous change. It measures how fast the quantity, the variable that you are observing is changing in that instant that you are observing it. We are going to learn that the velocity is the derivative of position function. And as you are paying the ticket, you are not paying for your average velocity. You are paying for the velocity of the instant where you were clocked. So we are going to make clear distinction in this class between instantaneous and average. And instantaneous is going to be the derivative. Those of you going into business, economics and so on, you might have interest in that subject. I say might because a lot of people go for things for whatever reason, I don't know. They hate every single second of education and then they hate the rest of the life because they're doing now that thing. Anyway, yeah, choose wisely. We are going to look at the average cost of, let's say, production of a product and marginal cost of the production of a product, and those two are not the same. So we'll see that as well as we move along through the chapter 3. And you will understand the other courses because everything starts with math as a base, and then everything else is going to be the application of it. So all of the physics and all of the chemistry and all of the business and economics and whatever else, those are just going to be our abstract ideas channeled into a very narrow application. So call it a business, call it economics, call it chemistry or physics or nuclear physics or whatever the hell you want to call it. Engineering is just going to be this one little track that you take to wiggle out of here. But this is where it starts. So before this, we used to hit 2 rocks to wake fire, right? Today, calculus, about 200 years of other math concepts and so on, we get to flip the switch and have the lights. Now imagine what else can come of the mathematics that we have today that we have no application for. Is just the hyperdimensional numbers. The complex numbers are just 2D. And that was enough for this. It powers everything on the planet. Alternating currents. Complex numbers. All right? Imagine what can you do with a hyperdimensional number. You can put as many dimensions to a number as you want. When 2-dimensional number is able to do this. And a 1-dimensional number is able to do 1, 2, 3, 4, 5, 6, 7. See the order of magnitude. So, it begins with the calculation of the derivative. Now, we introduce the idea of the derivative, and with this red sentence, you will have the concept of what the derivative is. Now our job for the rest of the chapter 3 is to see what are the methods of computing these derivatives easier so we don't have to suffer through horrors of taking the limit every time we need the derivative, and trust me, we need derivatives all the time. You also noticed that the entire mechanics of solving problems are mechanics from 2.3. So now I challenge you to go back to 2.3 as your exam prep and see that at one point in the homework you are asked to compute the limit. You are asked to compute the you are asked to compute the limit as h goes to 0 of 5 over x plus h minus 5 over x over h. This is a problem in 2.3. I get to ask the same, so this is 2.3 question. I get to ask the same question in 3.1 this way. Find the derivative of f of x equals 5 over x. So if I ask you the thing on the right, you will eventually have the step on the left. At which point, chapter 2 and chapter 3.1, section 3.1, have the same calculation. So this is why I said your 3.1 is technically included on the exam. All I need to do is to avoid using word derivative, but the mechanics of the problem are identical. There's no difference. You learn the mechanics of computing these problems in 2.3. And that's where you're going to go. If you're having issue with anything I wrote here for calculations, you will go back to 2.3 and learn that. So now, how do we solve this problem? And we end the day. Go away, keyboard. So what I do is I find the common denominator and I subtract 2 fractions. When you're looking at this problem, it is obvious that that's the only thing you can do. There is no rationalizing, there is no factoring. The only thing you can do is to subtract 2 fractions and hope that something good will come out of it. So as you do that, you have the common denominator of x times x plus h, and in the numerator, the cross multiplication will give you 5x minus 5x minus 5h. And everything is divided by h. Now this is your main division line. So it's important to have the main division line longer than all other lines. Because it helps you to set this over 1 under h. So now we have limit h goes to 0. To first of all, this 5x dies, right? And now what you have is 2 that are far apart multiply on top, and 2 that are close by multiply on the bottom. So negative 5h times 1 is negative 5h. And what you have here is h times x plus h. Wow. Denominator. These are all factors, so I can cancel. H dies with h. So what I have is the limit h goes to 0 of negative 5 divided by x plus h. Will the calculation be bothered by me plugging in h equals 0? What? Do I get 0 in the denominator if I plug it? No, right? So, since we don't get the 0 in the denominator, we are allowed to plug it in. So by h going to 0, we get negative 5 over x squared. So we say for f of x equals 5 over x, the derivative f prime of x is negative 5 over x squared. And we just proved that because we did the entire derivative procedure through limit, right? And we got this answer. So the last formula that I'm writing is that f prime of x is defined as the limit h goes to 0, f of x plus h minus f of x divided by h, and that is why we are all alive here taking this class. That was the reason for you to wake up this morning. Bye.